Okay. All right, what's up guys? Mr. Fabella here, and today we're going to be finding the area of a triangle and a missing dimension of a triangle. We'll also be doing trapezoids as well. So this is kind of continuing right from parallelograms. Right where we left off with parallelograms, we're going to do triangles. First of all, one piece of vocabulary, congruent. So congruent means same size, same shape. So saying something is congruent is kind of like saying two things are equal, except it's not just talking about numbers like x equals 5 or 5.5 equals 5.5. It's talking about shapes. So the symbol for congruent is a little squiggly line over an equal sign. That means those two things are the same size and the same shape. So like this triangle is similar to this triangle, but if this triangle was copied, I copy it and I paste it, these two triangles are congruent. Okay. Side note, similar is just the same shape, and the symbol for that is just the kind of looking like a tilde, squiggly line. As a reminder from the last time we did this should look familiar. Perimeter of area and area of formulas, right? So we did the square, extended it to a rectangle. We made a rectangle a parallelogram by cutting off like a slice of it, like a triangle, putting it on the other side, and became a parallelogram. And it showed that the base and the height multiplied by each other would be the same as the area of a rectangle in that case. So now we have a parallelogram. We are going to cut that in half and then find a triangle. So when I say cut that in half, I mean you take a parallelogram like this, and I'm going to cut it right in half from one vertex to another vertex. That cuts it exactly in half. So that'll be shown right here. So as you can see, you have a parallelogram, same exact parallelogram. I cut it right in half, and there, I have that triangle. Okay, so I cut that parallelogram right in half. You have that. You can ignore this blue part, and I have a triangle. If I redraw that triangle right there, it has your height, which is perpendicular to the base. It has A, B, and then now you can have C. So if I'm trying to find the perimeter is just A plus B plus C. You just add up the three sides. The area, though, is pretty interesting. The area, since we just took half of the parallelogram, we have the area of a parallelogram right there. We say that's base times height, but we took half of it. So it's 1/2 times base times height. That's where you get the area of a triangle. The area of a triangle is also base times height divided by 2. Okay, so you have two things that are exactly the same: 1/2 base times height or base times height divided by 2. Just whatever you want to do first. Do you want to divide by 2 at the end, or do you want to multiply by 1/2 first? All right. Okay, so if I have a triangle like this, to find the area, you know it is 1/2 base times height. Okay, so you have to find the base and the height. So 1, 2, 3, 4, 5. So this is a base of 5. 1, 2, 3, 4, 5, 6, 7, 8. This is a height of 8. So you just fill in what you know. The area will equal 1/2 times the base of 5 times the height of h. So the commutative property of multiplication says you can multiply in any order. So you don't have to take 1/2 of 5. You could just go 1/2 of 8 times 5, which is 4 times 5, and this is 20. So it's not saying if it's inches or centimeters, so we're just going to say 20 units squared because it's area. So this is another example. The 8 is over here, which is kind of weird, but that is actually just the height, because this is the same as right here in the middle. So that's going to also be 8. So there are two examples here. There's 2 points here. One, the base isn't always just the bottom, because the bottom, you don't know what that is. The base is just perpendicular to the height. So in this case, my 16 is going to be my base. So 1/2 times 16 times my height, which is going to be 8. Okay, so going from left to right, this is 1/2 of 16 is 8 times 8, that's 64. This is centimeters. and then squared. Okay, so we've done area of a rectangle, square, parallelogram. We did triangle right now. Now a trapezoid. So first of all, before we even do the area of a trapezoid, we have to know what a trapezoid is. So a trapezoid is actually a quadrilateral. So maybe I'll put a picture over here of the Venn diagram of the different quadrilaterals. It's a four-sided figure, and unlike a parallelogram, it only has one set of parallel sides. So in this case, this is parallel to this, and the other sides here and here, those are not parallel to each other. The parallel sides are what we call the bases. You can tell they're parallel. You can tell they're the bases because they're the ones that are parallel to each other. Okay, so I'm going to show you what the formula for that is, but I'm for sure going to prove it. Okay, so maybe I'm going to cut to the proof of the area of a trapezoid and do that now. Okay, so I'm going to try to explain how to find the area of a trapezoid and how that's derived. So let's say you just have a trapezoid like that, right? Okay, so this trapezoid, let's say there's two parallel sides. So you have base 1 here and base 2. It has two bases because that's how trapezoids are. You have two bases and you have a height that is perpendicular to both of the bases. You don't have to worry about these two. All right? So how am I going to find the area of that? So this came right after parallelograms. So you know what I'm going to do? I'm going to actually make a copy of this. So let's see. I'm going to cut this out, and hopefully it'll work out that it'll be right next to it. Okay, so I cut this out, right? I'm actually going to trace over it. I'm going to trace over it so it looks like, so we have two of the same exact trapezoids. Okay, and let's remember this was base 1 and this was base 2. Okay? All right, I wrote the B there, but don't worry about that. So let's see, we have two trapezoids there. I put a B there, but that's okay, don't worry about it. We'll just clean that up a little bit. And actually, if I take this and I flip it over, and then I slide it over here, if I slide it over there, what shape is that? That looks like a parallelogram to me. A little bigger, so why don't I trace this too? Because we traced it to get the trapezoid on the left. We said this was B1, because this is upside down. This is B2. And then this is still the height. Okay. So the height is perpendicular to the base. And right here, we still have this, right? Good. Well, I said that was B1, but look down here. This is B2, actually. This is B2. Okay, and this is B1 up here. And this is B2. And the height is the same. So I have basically a bigger parallelogram. How much bigger? Well, I did two of these, so it's twice as big as this. So two of these made up this parallelogram, and that works for any trapezoid. If you do that, double it, flip it over, put it next to it, you're going to have another parallelogram. All right, so now for the area. So area of a parallelogram, we'll just say that's parallelogram, right? Area equals base times height. All right, cool. So this is a parallelogram. So what's the area of this parallelogram? Well, the base is this whole thing, right? And that's actually base 1 plus this base 2. Same down here, base 1 plus base 2 plus base 1. So I'm going to say base 1 plus base 2. That's the base. And the height is just the height. All right, cool. That's a parallelogram, though. So how do I find the area of just one? So just one is the same as the area of a parallelogram, but there's only one of them. This is 2, so I'm going to take 1/2 of that. And there you have it. That's how you find the area of a trapezoid. Okay, so hopefully that helped. Cut that in there. So, like I said before, the area of a trapezoid, we could ignore this part of the trapezoid. So a trapezoid is actually half of a parallelogram. So you find the area of a parallelogram and you divide it by 2. All right, so we'll do a couple of practice problems here. Find the area of this trapezoid. So first, if you don't know what to do, the first thing you should do is to rewrite the formula to find the area of a trapezoid. So I'm going to write area equals 1/2 base 1. What? So we don't know the area, so that's A. We're going to put in 1/2 base 1. It doesn't matter which one the base 1 or base 2 is. I'll say this is base 1 and this is base 2 and this is the height. So base 1 is 3 plus 6 and then the height is 3.2. And now you just go ahead and work this out. Remember order of operations, so I'm going to add first. 3 plus 6 is 9 times 3.2 and this is 4.5 times 3.2. And then you have 14.4. And then this is area, so meters squared. All right. So again, area means you could fit 14.4 little squares that are 1 meter by 1 meter into this trapezoid. That's what area means. Okay, the shape of Osceola County, Florida resembles a trapezoid. Find the approximate area of the county. So it's not going to be the exact area, but about what is it going to be. So first of all, I'm going to write what the formula is. So 1/2 height. Then I'm going to figure out what each part is. So the bases are parallel to each other. So this line here and this line here, those do not look parallel. This does. So I'm going to say base 1 is 48 and base 2 is 16. And then the height is perpendicular to the bases. That looks perpendicular to me and it says the trapezoid. So my height is 51. Okay, so I'm just going to fill everything in. 1/2 times 48 plus 16 times 51. And then just work through that. 1/2 times 4 times 51. And you have 32 times 51. And then you multiply that, it's going to be 1,632. And then this is square miles or miles squared. All right, so find the area of the figures below. You can pause it here if you want to try it on your own. All right, so this first one, I'm going to write the equation. These are parallel. So this is base 1, this is my base 2, and this is my height. Okay, so 1/2 times 5 plus 7 times 4. That's what my area is going to equal. So 1/2 times 12 times 4. So remember, you have to add the numbers in the parentheses first. You have to add the two bases first before doing anything else. Then we have 6 times 4, and we have 24 square inches. Okay, here, this one's interesting. What did you think you were supposed to do here? This looks like a weird shape, but it's actually 2 trapezoids, and it kind of cut it in half there for you. Okay, so you have to find the 2 bases. So those look like the 2 bases, right? So this is base 1, and this is base 2, 7 and 3. But what's the height? See, the tricky part here is the height is not 8. The 8 is all the way from here to here. But since they're exactly the same, we can say that the height is half of that. So we can say the height is equal to 4. So now fill that out. Area of one of the trapezoids is going to be 1/2 3 plus 7 times 4. So 1/2 of 10 times 4, 5 times 4 is 20. So if you're done there, that's why I wrote the 1 over here, because that's for one trapezoid. So you just have to multiply that by 2, 20 times 2, and you have 40. So 40, and there's no units there, so 40 square units. Okay? Okay, so 40 units squared. Hopefully that helped, and I'll see you guys next time.